Alright, so today we learned about powers of 10. So make sure to, at any point, make sure to pause this video in either, in your notebook, create and copy this chart. However, I also put in Google Classroom, there is an assignment under 9/21/2020 that is titled Powers of 10 Notes. So you can go in there and this chart is already created for you and you can just type in all the blanks in the chart. So I'll save you a little bit of time. But anyways, pause the video, get it down somehow, some way. Okay, well first off, to review something that we're going to need, we need to talk about exponents. Now, exponents is a little number that's attached to a big number, and what it tells you, the exponent, the little number, it tells you how many times to multiply the big number, which is called the base, by itself. So 10 to the 4th power would be 10 times 10 times 10 times 10. And what you'll see is there's something special about when we take 10 and we start putting exponents on it. There's certain patterns that we see. So that's why it's an entire topic on its own. Okay, and now there's 3 different forms we need to talk about. One being exponential form. This is where it's just like the form I have it in right here, where we still have our base and we still have an exponent attached to it. Exponent, exponential form. Makes sense, right? Expanded form is like this that I have here. It's where we actually take our exponent, but we write out the multiplication. We say, okay, well 10 to the 5th, that means 10 times 10 times 10 times 10 times 10, 5 tens there being multiplied by itself. And then lastly, we have standard form. This is where we, actually do the multiplications. We do 10 times 10 times 10 times 10 times 10. You would put that in your calculator, and you'll see that it's a big number. It's 100,000. Well, what you're going to see as we decrease, I wanted to go ahead and start from a really big number, 10 to the 5th, 100,000 after you multiply all those 10s together. Let's see what happens when we just decrease our exponent by 1, 10 to the 4th. Well, that means that we're only multiplying by 10 4 times. 10 times 10 times 10 times 10. Which is a less number, right? Because we're losing a 10 on the multiplication. We're dropping it. And that's only equal to 10,000. Okay. So maybe that doesn't mean anything. Let's see. Let's go one less more. 10 to the 3rd. Now we multiply it by itself 3 times. 10 times 10 times 10. Oh wait, now we only have 1,000. So notice how we keep decreasing. 10 squared, 10 times 10 is 100. And notice how, and I'm going to kind of switch to the other page real quick. Notice how we have a pattern here. You can ignore this one for a second. That positive exponents, right, we got some pretty big numbers here. We got some pretty big numbers for positive exponents. And also, just in case you didn't catch it, the exponent tells you the number of zeros in standard form. So if you look at it, 10 to the 5th being 100,000, 1, 2, 3, 4, 5. Oh, 5 zeros. 10 to the 4th, 1, 2, 3, 4. Oh, 4 zeros. 10 to the 3rd, 1,000, 1, 2, 3, 3 zeros. 10 squared is 100, 2 zeros. Now, any number to the 1st power is just itself. So 10 to the 1st power is just 10, but it still follows the pattern. 1 is my exponent. I have 1 0. And then this is one you just kind of got to memorize. Any number to the 0 power is positive 1. It's not 0. That's a common mistake. Positive 1. And it still follows the pattern because there's no zeros on this 1, right? So that's kind of the shortcut of the powers of 10, the pattern there. Because each place value is just 10 times the previous, like ones, tens, hundreds, thousands, 10,000s, 100,000s. Increases, each place value increases by times 10 each time. Now, what you probably possibly have never seen before is now negative exponents. So I'm going to zoom in on it. We could even go into negative exponents. And what negative exponents really mean is that now we're getting into small numbers. We're getting into decimal numbers. Okay, so it's even less than the base that we're putting it on. And a negative exponent is just telling you, the mathematician, the reader, that something needs to be done to it. And what that thing is it needs to be thrown into the denominator of a fraction. So 10 to the negative 1 is just telling me, hey, this 10 is not in the right spot. I need to do something to it. I need to put a 1 in my numerator and throw my 10 in the denominator. Because really it's 1/10. We're going even less than 1. We're going back a decimal spot, back a place value from 1. So 10 to the negative 1, you throw the 10 on the bottom, you make the exponent positive. Oh, now it's 1 over 10 to the first power, which is just equal to 1 over 10, which is 1/10. Written in decimal form, that's 0.1. Then if we go to 10 to the negative 2, that's 1/10 times 1/10. 2 1/10ths being multiplied by each other because there's 2. And that's just the same thing as doing the shortcut that I showed you here. Throw that 10 in the denominator of a fraction, put a 1 on it, 1 over 10 squared, which 10 squared, we saw up here, is 100. So that's the same thing as 1/100th, or 1 over 100, which a decimal is that's still 1/100th, 0.01. And notice the zeros this time. This is the key, noticing the zeros. My exponent is 1, well, negative 1, and I have 1 0. It's just in front of the 1 this time. I got a negative 2 here. I still have 2 zeros. They're just in front of the 1 this time, and I'm getting smaller and smaller. I'm going back a place value. So look at 10 to the negative 3. 1/10 times 1/10 times 1/10. That's 3 1/10ths being multiplied by each other. That's the same thing as 1 over 10 to the positive 3, because when you throw it under, you make it positive. And we saw up here, let me pull this down, that 10 to the third is 1,000. So that's 1 over 1,000, which is just 1 1,000th. Still the same thing in decimal. 3 zeros out in front of that 1. That 1 is now in the 1,000ths place. Keep going. 10 to the negative 4. 4 1/10ths being multiplied, or 1 over 10 to the positive 4, which is 1 over 10,000, because we saw 10 to the positive 4 is 10,000. So now we have 4 zeros in front of the 1. And 10 to the negative 5, 5 1/10ths being multiplied, 1 over 10 to the positive 5, 1 over 100,000, and 5 zeros out in front of that 1. So you'll see that negative exponents, let's go back to our patterns. Oops, you can't see that. Back to our patterns that I wrote kind of on the second page. And if you're in the Google Docs, in Google Classroom doing these notes, you'll see that the patterns question is right below the chart. You'll see the negative exponents are used to make really small numbers. These are really tiny numbers as we go that far back in decimals. And something I want to point out for the negative exponents that's really important, you have to include the 0 in front of the decimal. Got to include that one. Okay. So let's do just a couple quick questions. So we already kind of talked about the pattern. The exponent tells you the number of zeros in standard form. So let's take a look. How about 10 to the 6th power in standard form? Well, my exponent is 6, so I need 6 zeros behind that 1. 1, 2, 3, 4, 5, 6. And my number is 1 million. As you start to get a higher exponent, these numbers are going to get huge. Just concentrate on the zeros, though. That's the pattern. 6 and then 6 zeros. Exponent 6, 6 zeros. Okay, here we got 10 to the 9th. Got 1, 2, 3, 4, 5, 6, 7, 8, 9. That's $1 billion. Now we're getting into like Bill Gates, Jeff Bezos money. 1 billion is that, because it has 9 zeros. That's the important part. 9 exponent, 9 zeros. Okay, what if we got 10 to the negative 7? 10 to the negative 7. Well, we got 7 zeros. 1, 2, 3, 4, 5, 6, 7. But now they're in front of the 1 because it needs to be a very small number when we are going of a negative exponent that large. Negative exponent of 7. 7 zeros out in front. This is an extremely small number. Where you start to see these numbers is like when scientists talk about like atoms and stuff. You start talking about really small numbers because atoms are really tiny. Okay, and that is that for the powers of 10.